Okay, so in this video, we're going to take a look at topic 1.2, the production possibilities model, which is in module 3 of the Krugman textbook. And in this video, I'm not going to actually type anything. I'm just going to draw some pictures. So I would encourage you, if you have this review guide digitally, to have a sheet of paper next to it where you can draw some of these graphs. So let's get started. Draw two PPCs, one with increasing and one with constant opportunity costs. And oops, I'm going to switch to my pen here. It looks like, so I'm already having technological snafus, that we would say our own two goods. So we're just going to make up two goods here, maybe guns and butter or capital and consumer goods, I don't know, pizzas and calzones. So let's start with pizza, because I like pizza, and calzones, because I like calzones. And what we would see is a company that makes those. They have really similar ingredients and they're really similar manufacturing process to make a calzone and a pizza. They're basically the same product. A calzone is a folded over pizza. And so anytime you change from one to another, in other words, you go from 1 unit of calzone to 1 unit of pizza, you increase a pizza and you give up a calzone, the ratio is the same throughout the range. The ratio stays constant is what we would say. So in other words, when you go down the line, right, the ratio of what you gave up stays exactly the same. And it stays the same both ways. So if you start giving up pizzas, right, you're going this way, then you get the same amount of calzones throughout the entire range of all the pizzas that you make. So that's why we call it constant opportunity costs. That's why. Now this one up here we're going to say is pizzas, because I like pizzas, and we're going to say robots. So imagine a company that makes just pizzas and robots. Well, those have really different kind of ingredients in a way, and they require different skills to make them and all kinds of things. The machinery is different. So what we would say is the first couple of units of, oh, oops, that was a little tricky there. I had a little trouble. We're going to fix that. The first couple of units of the object that you decide to make are, you're only going to give up basically the resources that were not terribly useful. So let's imagine that we're going this way down this curve. And what we're going to find is that as you make one pizza, two pizza, you give up only a tiny amount of robot. And that's because when you reallocate production toward pizzas and away from robots, you're going to basically say, all right, let's get the person who's really good at making pizzas to make pizzas. And as it turns out, that person is not very good at making robots. So we don't give up very much in the way of robots to get quite a bit of pizzas. But as we start to squeeze out more pizzas, we start to lose more and more robots as a result of the problem of adaptable inputs. Basically, that's a fancy way of saying that the person who's really good at making robots probably is not that good at making pizzas. So in order to squeeze out that last pizza, you have to give up a lot of robots. And it works the same way if we move backwards. That basically, when we reallocate and say, let's make a couple more robots, well, the first pizza that you give up, that's a pizza that you gave up, and it's only going to cost you a little bit of pizza, just a little bit of pizza, to get that full robot. That's because you're going to reallocate the first worker back. You're going to say, well, you make robots, and that's what you're good at, so let's have you make robots. And so you don't give up very many pizza because they weren't very good at making pizzas, but they are really good at robots. And so we'd say that it increases opportunity costs as you move both directions. So this is the increasing opportunity cost, and it is for both goods because you actually can't have it mathematically for one or the other. Now let's label a couple of points on these. Inefficient or unemployment is going to be anywhere beneath a curve. So any dot beneath the curve as long as it's bounded by the two axes. Efficient or full employment would be any point on the curve, right? And so it could be a full allocation to just pizza, for example, or a full allocation up here to just robots. That's still efficient, but it's counted as full employment. Beyond full employment is any point out here, and that would be kind of unsustainable. And growth, and this is a little bit hard to show now that I've written all that out here, growth is just the curve shifting out, right? So either one would look like this. The curve shifts out, and that actually says you've got more capacity to create. Now, we're going to do one last thing at the bottom of this page, and that's to show what would growth look like if it only affected one type of good. So if, for example, and I'm going to draw both, right? And it says on the other PPC above, but that's really messy up there. Imagine if basically you got better at pizza, right? You got better at pizza, but not about robots. Well, this curve just kind of shifts out like that. And this part stays the same. And like this one, if you got better at calzones, but not at pizza, that would be a little strange. It just kind of shifts that curve up along this axis. So it basically stays the same and then kind of rotates the curve, actually, is what's going on there. So that's what's going to happen if there's growth in only one type of good being produced. So hopefully this helps you make sense a little bit of the PPC. I'll see you next time.